Hi all, welcome to Security and Privacy in Cloud and myself J. Lavanya, Assistant Professor of CSE Department. Let's dive into the concept of cloud security concepts, and here we are going to discuss about the basics of cryptography. So let us give me a brief definition of it. So cryptography is nothing but it's the science of secret or hidden writing or hidden messages which was used before like history. And here if you take this is a practice of developing or using some coded algorithms to protect and obscure transmitted information so that it may only be read by those with the permission and ability to decrypt. And here if you take there are two main components. The first component is that nothing but encryption. Second is nothing but authentication and integrity. Let me say one by one. So what is meant by encryption? It is nothing but the practice of hiding messages so that they cannot be read by anyone other than the intended recipient. And for example, if a sender is receiving or sending some messages to the receiver, he cannot read or unless he is giving some secret messages or code to the recipient. So that is one of the example for encryption. And what is meant by authentication and integrity is nothing but ensuring that users of data or resources or the persons they claim to be and that the messages has not been surreptitiously altered. Here if you take these are commonly used in cryptography. So cryptography if you take has become an essential cybersecurity tool for protecting sensitive information from hackers and other cyber criminals. And along with that, if you take here, we will be having some four main principles which is followed for the encryption process. First one, confidentiality. Second one, integrity. Third one, non-repudiation. And fourth one is nothing but authentication. So if you take is about the encryption, cipher is a method for encrypting messages. And second point, encryption algorithm are standardized and published. The key, which is an input to the algorithm, is secret that is known by only the sender. And the same key is used for encryption and decryption. It is called as symmetric encryption. If different keys are used for encryption and decryption, it is called as asymmetric encryption. In this diagram, you can see like they are using some plain text followed by encryption algorithm, followed by ciphertext, followed by decryption algorithm, plain text. Here, if you take on the left hand side, they are using the key A, right? So the key A they are using. And if you take on the receiver side, they are using the key B. So they are using the different keys for encryption. So this is an example for asymmetric encryption. For example, if you take these type of encryption, some plain text, for example, if I'm giving like hello, okay, if I'm giving like hello in the sense as a plain text, uh, there are so many encryption algorithm which is followed in a cryptography technique. Say like RSA, SHARP, DES algorithm. Okay, so if I'm sending the message as hello in the sense, this plain text will be using some encryption algorithm and in turn it will be made to a ciphertext. Say for example, like A or L, something L or E, it will be just encrypted and it will be sent back to the decryption algorithm. So there are so many decryption algorithms, which in turn it will be the receiver what he will be doing, he will be just using the key B to decrypt that particular message and in turn it will be passed to the plain text which will be replicated as hello. So this is the process of encryption. And second is that symmetric encryption. As we have seen in the previous slide, algorithms in which the key for encryption and decryption are the same is called the symmetric. Example is Caesar cipher. So in Caesar cipher, if we take, It'll be transporting each letter of a message followed by three letters, which will turn the word cat into FDW. So, like replacing from A to Z, if you take, will be replacing three values, or you can give like four values based on the key you're giving. So this is called as an asymmetric algorithm. So there are two types. First one, block cipher. Second one, string cipher. If you take the block cipher, here we'll be encrypting the data one block at a time. Typically, it uses 64 bits or 128 bits, and it is used for a single message. And if you take the second type of symmetric algorithm, it is stream cipher. So here we'll be encrypting the data one bit or one byte at a time and use its data as a constant stream of information. And some of the main attributes of symmetric algorithm is that its speed, efficiency, and confidentiality. So speed is nothing but like encryption process, which is comparatively fast, and efficiency. If we are going for single key encryption, in the sense it will be suiting for large amount of data and requires only fewer resources. Confidentiality is nothing but which effectively sources data and prevents anyone without the key from decrypting the information. So this is all about symmetric encryption. Next one is then asymmetric encryption. So here it uses a pair of keys for encryption, and it's otherwise called as public key cryptography, and it uses public key for encryption, private key for decryption. And the data that is encrypted with a public and private key requires the both public key and recipient private key to be decrypted. So here, messages encoded using the public key can only be decoded by the private key. And here, the public key cryptography, that is nothing but asymmetric encryption or cryptography. It enables secure key exchange over an insecure medium without the need to share the secret decryption key, because the public key is only used in the encryption but not the decryption process. In this way, asymmetric encryption adds an additional layer of security because an individual's private key is never shared. And here in this diagram, you can see the secret transmission of key, like from public key is used on the, what is that, the encryption side. And similar to that, on the decryption side, you can go for some private key. So you're using some key pairs for both encryption as well as decryption. So this is an example for asymmetric encryption. If you take the main attributes of asymmetric encryption is that security, robust, and resource intensive. So security is nothing but asymmetric encryption is considered more secure when compared to symmetric, since it uses both public as well as private key. The second one is that robust, and third one resource intensive. So next one we are going to see is about the applications of cryptography. So let us see one by one. The first one is that computer password. So what is meant by computer password? Like in cryptography, it is widely used in computer security, particularly when creating and maintaining password. When a user logs in their password, which is hashed and compared to the hash that was previously stored, passwords are encrypted before being stored. And here in this technique, the passwords are encrypted so that even a hacker gains access to the password database. They cannot read the password. So that is what an application of computer password. Second one, it's a digital currency. So if you take to protect some transaction, or or digital currency to prevent fraud transaction like Bitcoin, you can go for some complex algorithms like cryptographic keys are used to safeguard such transactions, and making it nearly hard to tamper with that or forge the transaction. So this is all about digital currency. Third one is nothing but secure web browsing. So online browsing security is provided by the use of cryptography, which shields the users from eavesdropping and man-in-the-middle attack. And public cryptography is used in secure socket layer, that is SSL and TLS protocol, to encrypt the data sent between their what is that, like web server and the client, establishing a secure channel for the communication purpose. And next one is that electronic signature. So electronic signature is nothing but it serves as a digital equivalent handwritten encryption. It uses to sign documents and are also created by using the cryptography, and it can be validated using the public key cryptography. In many nations, electronic signature are enforceable by law, and their use is expanding quickly. And next one is that authentication. If you take authentication, it's here cryptography is used for authentication in many different situations, such as when accessing a bank account or logging into your computer or using a secure network, or employed by authentication protocol to confirm that the user's identity and confirm they have required access rights to their resource. So that is all about authentication. The next one is that cryptocurrency. So cryptocurrency, now cryptography is heavily used by cryptocurrency like Bitcoin and Ethereum to protect transaction, sorry, fraud, as well as to safeguard the transaction, making it nearly hard to tamper with or forge the transactions. So this is us about cryptocurrency. So these are the applications of cryptography. Next one is that types of cryptographic algorithm. So the first one is that AES, DES, RSA, and SHA algorithm. Let us see one by one. So the first one is that AES, that is Advanced Encryption Standard. It is a popular encryption algorithm which is uses the same key for encryption and decryption. So it is a symmetric block cipher algorithm, which uses like 128 bit, 192, 256 bits. And it was developed by John Damon and Vincent Reichman in the year 2001. And apart from that, it supports substitution technique, permutation technique, and mixing, which is used for secure encryption. And the transmitter and the receiver share a key for symmetric encryption. And I'll just explain the means of the diagram. And here there will be some Alice and Bob, which securely exchange a secret key before sending a AES encrypted message. So the Bob can decrypt the message using the same secret key. So if you take this diagram, there will be some plain text and followed by some ciphertext. There will be some round n based on the bits you are going to use. It may be of 128, 192 or 256 bits. And once a plain text is going to the round 1, here it uses substitution technique, permutation as well as mixing technique. So this is all about AES algorithm. Next one is that DES, Data Encryption Standard. So it is a symmetric key block cipher which is published by National Institute of Standards and Technology. And here it is all the encryption algorithm, that is used to convert a 64-bit plain text into a 48-bit encrypted ciphertext. It uses symmetric key like this, both which means like encryption and decryption uses the same key. It's a kind of word by today's standard you can use as a basic building block for learning newer encryption algorithm. And it's an implementation of Feastel cipher. It uses a 16 round Feastel structure. In the previous AES we have seen based on the bits, the rounds will be differ. And here it uses standard 16 round. The block size is 64 bit. Though the key length is 64, DES has an effective key length of 56 bit since 8 of the 64 of the key are not used by the encryption algorithm. So next one is that we'll see the diagrammatic format for this particular DES. Here, the 64-bit plain text will be just giving us an input for the initial permutation. So this is nothing but it's a one block actually. Like there's round one. So in round one or the block, it uses some initial permutation round one till round 16. And in that parallelly, you'll be having some round key generator. Here it uses a 56-bit cipher key. And for each round, there will be a separate key uh, of size 48-bit. So similar to that for round 1, round 2, round 3 till round 16, we'll be having each bit as a 48-bit and the final permutation followed by the 64-bit ciphertext. Okay. So this is all about the DES. And the next one is nothing but RSA. So RSA is one of the first public key crypto system which is based on the mathematical difficulty of factoring large prime numbers, and it is an asymmetric cryptography which uses two different keys for encryption. The RSA algorithm works on a block cipher concept that converts a plain text into ciphertext and vice versa. And the RSA, the full form is Rabbit Shamil Edelman, who are the inventors of RSA. And here it allows secure data transmission and digital signature, making it foundational in modern cryptographic practices. So these are the key features of RSA. Now, RSA lies in the robust key generation and security features. The key pair generation process involves selecting two large prime numbers, that is P and Q, which are multiplied to produce the N. The public key consists of N and an exponent E, while the private key comprises N and another exponent E, which is calculated to ensure. So this is a formula. So E multiplication, that is the exponent cross the particular variable, that is the exponent, is the modulo of 1 more phi of n. So phi of n is nothing but Euler's joint function. So this is nothing but Euler's joint function. So by means of this particular formula, we can able to calculate the RSA. So here, if you take this is the RSA concept, you can see here like there will be a sender and there will be a receiver. And here from the message, you can constantly share the public key as well as the encryption key through some popular like through a communication channel. Here in turn, it be received by the receiver. Here it uses encryption key, private key, and the original message will be decrypted in the receiver side and will be shown to the user or the client. So this is all about RSA. And here it uses the formula E dot D is equal to that 1 mod phi of n. That is all a joint function. Next one we are going to discuss is about SHA. So SHA is nothing but it uses some secure hashing algorithm. A SHA is nothing but it's a modified version of MD5 and it is used for hashing data and certificates. A hashing algorithm shortens the input data in a smaller form that cannot uh, be understood by using the bitwise operations, modular additions, and compression function. So here, if you take in this particular SHA, it uses some fixed length digital fingerprints of input data that is known as hashes, and SHA variations like there are so many versions like SHA-2, SHA-3, SHA-60 that are commonly used to ensure data integrity and authenticity. Tiny change in an input data which drastically modifies the hash output, indicating a loss of integrity. Hashing is the process of storing key value pairs with the help of hash function as well as the hash table. And if you take hashing, that is mainly commonly used in all over the world in case of cryptography. Why? In the sense, because without hashing you can't able to secure your messages. So that is why we'll be going for this kind of hashing process. And it involves three main components like input, hash function, as well as output. So input, what type of data into the algorithm you're going to give is input. It can be a musical file or paper, or even a single input data to produce a single output. And the second hash function is nothing but the central part of the hashing process called as a hash function. Here, in this function, we'll be taking the input data and applies a series of like mathematical operations, resulting in a fixed string of characters. And last one is the output. If you take hash output, unlike the input, the hash process output or hash value has a set length. Here, the hash value is a string of characters and numbers that a hacker might not be able to read, keeping a person's information private. As each hash value is distinct, hash values are also frequently referred as fingerprints. And if you take the benefits of hashing, there are so many benefits. Like if you take the first one, data integrity, efficient data retrieval, digital signature, password storage, fast searching, efficient caching, cryptographic applications, space efficiency, blockchain technology, data compression, and database management. And what about if you take the disadvantages of hashing, risk of collision, non-reversible, limited sorting, space overhead, keep dependency, difficulty in setting up. So, like there are hashing, the SHA-256, SHA-512, and bcrypt, it will be used. And the common message digest function is that MD5 and MD6, which results in a digital signature. And here you can see the diagram. So this is a common diagram where you can see, like as I told, plain text will be there, and some hash process or hash function will be done, and sorry, hash function, and based on that, the hash value will be produced. Okay, so this is all about the SHA function. And one more thing, if you take hashing, it is often used to store password or create digital signature and verify the data integrity. And here, if you take, there are so many encryption which requires both encryption and decryption to convert data between the plain text as well as the hash value. So only, we'll be using some hash function concept in which you'll be going for some SHA-255 or 256, and based on the concept you're using, it will be varied. So thank you. So this is all about the hash function. So thank you all. I hope this video will be useful. Thank you so much.